Atoms are identified by the number of protons in the nucleus. Each type of atom has a different number of protons in the nucleus. The number of neutrons in the nucleus, however, is variable. The atoms of a given element, for instance carbon, which has 6 protons in the nucleus, might have 7, 6, or 8 neutrons in the nucleus. Each of these different types of carbon atoms is called an isotope. Most elements in the periodic table have different isotopes. If we take a bunch of carbon atoms and look really closely at them and zoom in on the nucleus, we'll find that about 98.93% of our carbon atoms have 6 neutrons, and about 1.07% of our carbon atoms will have 7 neutrons. And a very, very, very tiny, small fraction of those carbon atoms will have 8 neutrons. Because each carbon atom has 6 protons, the mass number, or the number of neutrons plus the number of protons, is 12 for the carbon atoms that have 6 neutrons, the majority of the carbon atoms in our sample, and the mass number is 13 for the carbon atoms that have 7 neutrons, because 6 protons plus 7 neutrons equals 13, and the mass number for the smallest fraction of carbon atoms with 8 neutrons is 14. All of these atoms are carbon atoms because they have 6 protons. They all behave chemically the same. The only difference is their mass, and the ones with more neutrons will be heavier. Each of these different types of carbon atoms is called an isotope of carbon. As an analogy, imagine a pile of M&Ms. They're all M&Ms, but you can tell them apart because they have different colors. They all taste the same, but they have different colors, and so you could sort them into different piles based on their colors. This is an analogy to isotopes of atoms, where all atoms of a given type, all carbon atoms for instance, behave the same, but you can tell them apart because of their mass. You can sort them into different piles according to mass, but they're all carbon atoms and they all behave identically.